Hi, I'm Joshua Finn from J&H Aerospace. This is part 5 in our series of reviews of elastic launch glider kits for the 2018-2019 season for Science Olympiad. Originally, this was a 4-part series. So we started out by reviewing the Scholastic by Retro RC. We reviewed the Guru Engineering Tech glider. And then we reviewed the Freedom Flight Models glider. We did, unfairly probably, but we did. We compared them to the Super Protege. And so far the Super Protege has come out on top. It's probably going to stay that way for this season, and I think the ability to do that with it plays a substantial role. But even before I finished the series, someone came in and posted, so here we'll bring this up, when I got to part 2, and my phone's going to be ornery, here we go. Terry Epperly posts, "One I don't see on your list is the SCImOn 30 by Stevens Aero. That was common at our regional competition, though I believe it is a very good starter build, maybe not, and maybe capable of high teens of flight time." Okay, so Terry, the reason, and I mentioned this in there, the reason I didn't review the SCImOn is it's a little more equivalent to our Pt.5 Science Olympiad. Now, the purpose of this airplane was for some pretty specialized activities. So some of the state-level Science Olympiad contests were held in high ceilings. And since we already had a Pt.5 that was suitable for high ceiling indoor flying, I created a lighter version of it that would be suitable for the higher Science Olympiad contests. I've gotten zero feedback, frankly, on where this thing stacks up. Now, outdoors, I've gotten flights of right around a minute with this airplane, but that's launching to about 100 feet. I know there were some 60, 70, 80-foot sites where contests were held, and this airplane would excel at that. It would be doing in the high 40-second range there. So the bottom line, though, is at one point we were 2.5 weeks behind on orders, and I had people coming to me due to a vendor which will remain unnamed, basically that left people in a lurch and left them in a lurch very badly, and they were coming to me last minute saying, you know, I have a week before my contest and I've been told that I'm not getting a kit. Can you help me out? And at those points I was like 2.5 weeks behind on orders because everybody was coming to me with that, and I couldn't get materials in fast enough at the time. We'll be doing better with that next season. But anyway, I was sending them wherever I could, and a lot of them I sent to Stevens Aero model because I figured, being a little bit bigger of a manufacturer, Stevens would be able to get their kits to them on time. I don't know where all that stands. I know one person I contacted said they did get their kit, but then it broke in the contest. So, I don't know. Bottom line is, I went and I ordered one, and because of what Terry asked, because I said, you know, it's unfair to not review all the planes, except when I get to the Right Stuff review series, you'll find I skipped one, with apologies to that company, which does make very good stuff. So, anyway, as you can tell, I have not opened this. It arrived yesterday. It took me about 4 days from time of order to get it. So pretty cool. Alright, so let's open this up. Very simple packaging here. So I've got my shipping receipt, and inside is my kit. I will say, alright, I want to show you, this is how it's kind of wedged in here. That's probably fine, but bear in mind that can get damaged. If you put fragile on your shipping stuff, that means step here. So, I'll pop this guy open here. It's pretty good packaging. It's got a cardboard backing in there. Looking at it, I'm seeing a bunch of 1/16 balsa and some 1/8 inch balsa. I have built some of Stevens Aero, well, I've dealt with Stevens Aero kits before. I have a few issues with some aspects of their structural design, meaning I crashed a 3D plane and plastered it pretty good. It is back in the air in someone else's hands, but I just decided that that wasn't for me. But the wood quality that Stevens uses is very high, and when you're looking at just laser cutting in general, Stevens has kind of become the industry standard on that, them and mountain models. Alright, so the first thing is we open this guy up and we've got the little flyer on here that gives the specs. 11.02 inches projected span. It's a little on the small side. That's only 28 centimeters, so you're giving up 2 centimeters. That is a big deal on these. It's 11.9 inches long, a little on the short side for me. Since, let's see, the shortest, alright, so the shortest one of these is the Freedom Flight kit, and you can tell from that, just from that, that means that airplane's over 13 inches long. 30 square inches, and they say a flying weight of 30, of 6 grams, which is about optimal for about a 50, 60 foot ceiling. Okay, so let me focus you down here, get all the other products out of the way, and just show you what's in this. So the packaging looks good, on par with what Retro RC has, and Retro RC I think is, frankly, has got the coolest packaging of the ones I've reviewed so far. So, so you've got some goodies here, including these big things that says, laser engraved in it, add to completed glider, extends fuselage to 32.5 centimeters. It's got 2019 rule written on here, not written, engraved. So there you go. You're already seeing kind of how Stevens Aero does stuff. They're into really high quality stuff, which is why this is a $35 kit. That it builds 2 very simple gliders. So you've got the little nose reinforcement things here with hooks on them. I'm not sure about that hook design, but we'll see how it goes. It looks like things could slip off a little easily, but I don't know, we'll find out. Some very nice super light 1/16 balsa for your tail surfaces. Kind of small tails to me. Sorry, this is 1/20th balsa. Let me get it right. You've got some 1/8 balsa for the fuselages. Feels about right on hardness, maybe a little on the light side. And then you've got your flying surfaces. And these do have a fairly, so you've got your wingtips out here and you've got your wing center section. This looks like it's a fairly wide wing chord, so let's compare this to, yeah, it's about, okay, so it's about 3 inches, so it is about on par with everything else. Let's see, that's significant, it's more cord than the Guru gliders, because right about here. Let's compare it to the Scholastic, which is a long-standing thing. Looks like a slightly more cord than the Scholastic as well. And I should mention these. This kit in its basic form has been around for several years. So there's enough parts, as you can see here, to build 2 airplanes. And so that's all of your parts. So fairly simple parts pack on this guy. Pack all this back together. Launch handle looks a little on the short side, but not really a big issue here. And this has an insert of plans in the instruction manual. We do like to review the instructions as well. So all of these, except for Guru, which does have a sort of a build video that it's restricted access, but they do have that as well. Alright, so you've got this 3-view drawing thing going on here. There's something I'm specifically looking for here, and I'm not seeing it. Anyway, what I was looking for is reference to when this model was designed, because I believe this one's been around for a while now. But anyway, have all sorts of nice engineering drawings here. It says not to scale, so like most of the kits, this does not include full-size drawings that I can tell. I know what the reasoning for that is. All the companies want to keep that kind of proprietary. And I am not going to plug myself too much, but I just want to mention with the original Protege, we included full-size plans. With Super Protege, we open sourced the whole thing. You guys ordered Super Proteges like crazy, and put food on my table, frankly. In spite of the fact that I put the free plans up there so anybody could build it from scratch. Just saying. I'm not off my soapbox. Alright, so here's the instruction manual here. It says it's version 2.19, so it was revised 21st of September 2018. And we'll go through all that. And so here we show all the goings on here. So basically the wing is designed to be built on its carrier sheet as a jig. Now this, I gotta say, is pretty cool. It's pretty cool. You know, I have my own way of doing things, but that's a neat way to build out your wing. There are fixtures further for aligning everything. Just in general, in terms of the build out, this is a very cool kit. It contains a jig for left and right handed stab tilt and whatnot. There are shenanigans that go on with how your rudder is installed. Yeah, that's pretty cool stuff. And then there are discussions on how to do your launch. And more setup and whatnot. This is some pretty good stuff about how to get your airplane to launch. And then they have a problem cause solution thing here. I can't remember if it was. I think this is the same. Okay. So this is included in the in Freedom Flight's stuff as well. This basic flowchart, and I knew I had seen this before. Don DeLoach, you've been mentioned. So this is from Don DeLoach's hand launch glider trimming chart. I can't remember where that was originally published. It probably came out of Max Out originally. Steven's Aero model is based out of California. I don't know what relationship they have with the Magnificent Mountain Men Club out there in Denver, but bottom line is, looks like they borrow from all of that, and that's fine. So anyway, before I get started on the build, I can just tell you, pretty cool airplane. I do want to look at one thing here though, this is just kind of a pet peeve of mine as far as if we're going for full performance. I want to see about if there's any instruction on sanding the wing. And so far, I'm not seeing that. Alright, so this is a concern that I see, because so far I'm not seeing any mention about sanding the wing to an airfoil. And I'm still not seeing that. So here's my concern here. Yeah, because I'm not I mean, it talks about pre-sanding, but yeah, I'm not seeing a key word in here, and that word is airfoil. So here's kind of how things go. So Freedom Flight gives you these sanding specs that are insane. Retro RC gives you a set of jigs to sand a thin sheet wing to this curved butt joint that forces a curve into the wing. Guru does something actually very similar to that with a curved pylon and so on. We at J&H Aerospace, what I've actually been teaching students to do most recently is to sand a bevel back to about 5 to 10% of mean chord throughout all of this, and then leave the rest of the wing flat. If you're looking to save weight, you sand the bottom of the wing to keep it flat and just sand it to the thickness of the flaps. With the Carbonette 12, I direct you, the Elastic Launch Glider Carbonette 12, I direct students to a video which describes sanding the correct airfoil into that wing. So, you know, I have dings with everything. I have dings with my own planes. This optimally would have used a carbon fuselage. Optimally, probably would have used a thinner wing. You know, we can go round and round the bend on that. On this, I welcome people to provide suggestions on this that can be done in a production environment. Meaning, telling me to get tail surfaces from Specialized Balsa is kind of out, because that's just not a practical option. So, you know, as far as practical things, I do have a concern about a not too cheap kit that doesn't tell you to sand the airfoil in. That being said, the rest of it is very well engineered. So we're going to build it out. We're going to give it a fair shake, like I have with everything, and we'll see where we end up from there. Alright, so we're getting started here with the build on this plane. And so the way that you do this is slide around here. Because we're separating the wing from the wing center section, that is, from everything else. I will mention upon inspection, some of the wood for the wing is a little bit on the hard side. Not necessarily really an issue. For a beginner's plane, it's perfectly fine. I think the main issue is that when you take this to a Science Olympiad contest against some of your stronger contenders out there, now you're at a potential disadvantage. So I'm going to pop these little dihedral jigs out. And as always, our folks at Stevens Aero Model pretty much produce some of the best kits in the industry as far as laser cutting quality and whatnot. Sorry for the interruption. There's a cat complaining about lack of food. Heard it from Caleb first. So this is how this fits. Oh, sorry. Can't see what I'm doing. There we go. Alright, so what we've done is we've glued these ears on, like so. And now, snip this in like so. Now, I can't tell if there's any toe. I don't think there's any toe out of the dihedral joints for for washout. Personally, I recommend if you're going to build a polyhedral wing that you should do so, but that's my take on it. I think you're also supposed to like assemble this and then whip the glue in or something like that, but I'm going to be a rebel. So these kind of zigzagged dihedral brakes like this are quite cool in terms of they are a little bit stronger. If you want an airfoil surface, though, they do tend to get in the way a little bit. Let's see here, I've got a piece of material that has not been lasered quite all the way through. I'm not going to throw rocks at that idea because any laser cut kit is going to have a certain amount of material that didn't get cut quite all the way through. And there's your wing. And that's literally all there is to it. So at this point you just snap this out. All done. Pretty cool way to do a wing. Very cool. Now, the catch to this is, since the wing is kind of captured back here at the trailing edge, you can't beforehand sand an airfoil back in here. And for like a Science Olympiad type application, that would be really handy to be able to, be able to run a razor plane along like that. And I really think that you could still engineer a structure that would allow you to do that if you secured the front of this wing as your little retainer thing that you do this on. Just my unsolicited opinion on the matter. And you can come along like so, and you can create an airfoil. I'm not going to go too deep into that, other than that this is just among those things you're able to do that do increase performance really quite significantly. Even, just rounding off a wing leading edge and whatnot, which the instructions say not to do. But I'm sorry, that puts you at a disadvantage if you're flying competitively. My glue did not dry all the way on that side. Tut tut. It'll harden eventually. Whatever. So, anyway, just my take on all of this. then maybe you could round all that off. Remove some aerodynamic drag. Alright, I've spent enough time on that. Let's go on to the next step. So we'll zoom back out. So, we have a dihedral jig that I am not. Get that part. Okay, there we go. Not a dihedral jig. It's a wing alignment jig that you build like so. So out comes our fuselage, pretty cool fuselage. And then the wing just slots on the top like so. So then all I have to do is put some glue on here. They say to use this little jig to do that. Make sure it's lined up correctly. It is. And so there, we're done on that part. And then, in our parts bag is a little piece of aluminum tubing. And now I just see something I missed out on. Okay, here we go. So the wing actually is intended to have a very slight, we'll call curvature here. Because the wing's mounting seat, and I saw this earlier and I forgot about it, is that there's actually some curvature here. So you do get a little bit of airfoil camber. But the reality is that camber is only going to be present for about this section of the wing. Anything outboard of that, by virtue of these dihedral joints, is going to be basically taken out. So take that for what it's worth. Back to our regularly scheduled programming. Now that I've stuff on that part, so you have this piece of aluminum tubing that you slide through right here, and the purpose of it is that when you pop off your nose reinforcement section here, you can then center that up and looks like we're going to have to sand the ends of this guy as it goes. Still not fitting. the issue here is this is toleranced real tight, and in this case it is toleranced a bit too tight. This is one of the lessons I've had to learn as well, is that you let certain things be a little bit loose in some cases, so that in other cases they don't end up so tight that middle schoolers cannot figure out how to make them do their thing that they're supposed to do. Anyway, once you've got that, then this locks in around like so. And you've got this little ballast tube right here. So what I'm going to do is I'm going to come back with some glue here. And lock this guy in place. And the result is pretty nice. I'm just going to leave the aluminum tubing in there because it's not going to hurt anything. Okay, so there we go. So, after that, I'll clear a few things out of the way and I'll be right back. Okay, so you have two types of setups here. So this glider is designed with markings for right-handed and left-handed launchers. And so what we're going to do is I'm going to pop out a horizontal stabilizer here. Since I'm right-handed, I'm going to choose this little guy instead of this one. And it is labeled back, so it faces towards the back. And so we fit this on here. Then we're going to slide our stab on as a test fit here. And if you look really closely, you can see that sets you up so this side of the stab is just a little bit higher than the other. Now personally, I tend to just twist the tail to the entire back of the fuselage to force stab tilt in on an as-needed basis. But for an outdoor hand-launched glider, that type of thing, not a bad idea. And then we can just take this guy back off. Now we grab a rudder fin. And I should mention, you want to make sure for your incidence purposes that this is pressed all the way up against the horizontal tail all the way along there. And since I am right-handed, I use the slot on the left side that is marked right-handed. And what that does is that gives me a very slight amount of left rudder. And make sure the rudder is straight up and down. It is. Good to go. Okay, so we have what looks like a glider at this point. So, that said, there are a couple issues that have to be dealt with here in just a minute. If I can get Yeah. So there are discussions elsewhere in here, and this shows that basically this is kind of a recyclement of an older design. And we'll get into some of that in a minute here. There's personal opinion. There's a flight dynamics issue here. So this glider is designed really short. Part of the why that works is because you've got a short nose, and that allows you to get away with this tiny little tail, because that means your nose weight is out here very close to your design center of gravity, and that means that it has very little moment of inertia in the pitch axis. So that means you can get away with a little bitty tail. Now personally, I don't like little bitty tails either way, but be that as it may, to comply with the bonus on the 2019 rules, they give you this little extension which makes the nose longer. Now, most people are going to rightly want to put clay further out here to use as little clay as possible. And the problem with that is now you have increased the moment of inertia about the center of gravity, which will make the airplane harder to trim from a dynamic perspective, particularly if your goal is a really, really snappy glide transition. Not that the average middle schooler is going to be able to achieve a snappy glide transition if their life depends on it and they spend, you know, a couple hundred hours trying to work that out. So that's kind of my soapbox on that particular aspect of things. But either way, you glue this little guy on, and I put mine on upside down. Yeah, whatever. It's only looks upside down because of the ruling on or the lettering that's engraved on it. So then they talk about just balancing it on your fingertips and whatnot, which is perfectly okay. I think for the amount of money you're paying for this kit with all the preformed jigs and whatnot, they ought to include a CG stand for this guy. And I simply say that because this is just a traditional balsa model, so I'd like to see that as part of all of that. Now I am going to balance the airplane by sticking clay up in this slot here. And it's still showing a little bit tail heavy. And I'm just building the airplane per the instructions on this. And now the airplane is perfectly balanced. So I'll stick the clay back in here. And the next question of this is, because I want to see all of that. We're talking about ballast in here, stab tilt. Sorry, I'm taking my slow, sweet time because I want to see what adjustments they are saying. Yeah, so they're just saying warp the tail surfaces and whatnot. And I'm on a solid plane like this. This is just like a carbonette. Don't be bending stuff. Use your little wash-in wedges, or yeah, gurney flaps. That's the technical term. I will go ahead and I will use. Unlike the others, I'm actually going to use the supplied catapult because reasons. You want to see how long. Yeah, so they don't say really how long of a catapult loop to use. I recommend it be fairly small, because they will come up and smack the glider if they're too long. And again, this airplane is derived from a long-standing design at Stevens for outdoor flying, and so that's part of my issue here is we're trying to just adapt an outdoor airplane with as few changes as possible for standard science Olympiad usage. And in high ceiling, that's a pretty good idea. Low ceiling, not so much. I would like to see a throwing reinforcement right here for students to throw it, just like we do on the carbonets. Just gives them a good way to get a feel for the launching and whatnot. I am going to give this a glide across the living room, and we'll see how well that works. And then we'll probably take it outside. Alright, so it immediately pitches straight up into a stall. And my concern with that is that's at the recommended CG. So, I cannot see any evidence that I assembled the airplane incorrectly. It has a little bit of positive incidence built in. What I'm going to do is I'm going to bend the left side of the stab down, and it's already splitting. This is 1/20th balsa is really too thick for tail surfaces that are that small at least. This airplane is going to be really loopy when I start throwing it harder. Gonna give it more clay. So, at this point, one of the things to note is I have completely filled that ballast compartment almost, and I'm still stalling. So I'm going to add, because I know I'm outside the design CG range already, I'm going to start cranking more down elevator, and I'm breaking the wood at this point. We're starting to glide and we're going to the right. Not good. And I'm not sure why we're going to the right, because we've got right rudder. Actually, I know where we're going to the right. This is going to be a no bueno. Remember what I said, we're outside the design CG range of this airplane. So if my CG is here where it's supposed to be, then my stab is going to be lifting. And so since it's tilted that way, it's going to lift this direction. I have had to move the CG forward. I'm getting close to the neutral point, or the center of lift of this wing, which means now my stab tilt, my stab is pushing down. So now it's pushing me to the right. Not good. So we're going to take some nose weight off, and we're going to add a bunch down elevator until this thing cooperates and plays nice with us. Alright, so back close to the design CG here. I'm going to add even more down trim. Getting there. Alright, at this point I need to re-glue my horizontal stab. basically I'm bending it down pretty aggressively at this point. I did take a little bit too much clay off. So let's see if we're starting to... We did at least start going around to the left. So I'm going to bend my elevator down even more. That's scary how much I've got that bent down. It is still not happy. I think I'm about to have to take this outside and get aggressive with it. Because the problem is that with these adjustments, we are getting way outside the design operating range of a lot of things on this airplane. That's better, but that's also completely neutral. Check one more time my CG. Alright. I'm balanced a teensy bit too far aft. So let's add a tiny bit of clay here. I figure it's okay to be forward of those marks, but probably not to be aft of them. Alright, now we're gliding okay. Time to go outside with it. Alright, so we're outside with this, with the SCImOn from Stevens Aero. Let's see what we can do here. Well, that did not go well. I think we're trimmed completely beyond neutral. Yeah, so it's punching in. Not good. Now, I will acknowledge there's lots of wind out here, but still, this airplane should be able to do a little better than that. So I'm going to have to trim this differently, and we're going to see how all this goes. Alright, that's looking more promising. So I'm taking out that down elevator I trimmed in there. Still diving in. And I am not liking how neutral that looks. Alright, so what I'm going to do is I'm going to try catapulting, launching this horizontally, and we'll see what it does. And you can't see it off camera. It went gliding off that way. It looked pretty good for a while, and then it started stalling again, so it needs more clay on the nose. So we'll be back in a minute. Okay, so added more clay on it, and I'll show you in a minute. It's happier now. Why I have an issue with that? The instructions specifically tell you to balance this airplane at a particular point, and then send you into a trimming guide that's based on that kind of general thing. This airplane is balancing probably almost 1/4 of an inch ahead of the CG marks, and that would be okay on like a Carbonet. We're very generalized on our CG marks, and we admit it. We don't talk a whole lot about locating at a particular CG because we tell you you're going to move the CG. You're going to move it a lot. But the Carbonet has a giant horizontal stab that lets you be off by 1/4 of an inch either way, and you can still get something close to a glide starting out. This airplane has a tiny little tail. That means you can't get away with those sorts of mistakes. And if you try to bend the tail to compensate, you're going to end up with a completely unstable airplane. Not like neutrally stable, like unstable. So let's take a look at where we are now. Sorry, it's windy, plane not happy, me not terribly happy. Let's just try catapulting it and we'll see how this goes. Hopefully I'll get it to curl back around so you can see it. There we go, and still gliding, looking good, and it just dove in on me, so it's still neutral. Alright, so let's take another go at this. If that's stalled, it may be okay. So I added some up elevator in hopes of improving things. Let's try another. Alright, so we're going up, pitching into a stall, and kind of pulling out. I shall now try a little bit of left bank. Better. And sorta okay, we'll see. Alright, conditions are not ideal out here, so bear that in mind. We'll try again. I'm going to add in a little bit of left rudder to pull it around. Let's see how that goes. Better, better. There we go. Nice glide. Nice glide. Let's see, I don't know how well that's showing up there. Still flying. Still flying. Stalling. Thunk. Alright, be right back. Alright, so we're going to try this again here with a little more clay on the nose because I think it's still a little off there. And we're in the glide. And there you are. There's a plane flying in the wind, struggling because the wind is bad. And now it's going to the right a little bit. Still flying, still flying, still flying. Down. Yeah, yet another tank. There we go. Glide transition. Still flying along. Looking good. Going back there in those trees at this rate. Ooh, that was hard. Alright, so what have we learned about the SCImOn 30 by Stevens Aero? A couple things. My final CG ended up about a 1/4 inch ahead of where's recommended, which is not too bad. The main issue is, I think that if you don't have a trimming guide, how, you know, what's the question here is, what is your probability of getting this airplane to fly with the supplied instructions? And, I mean, we saw the airplane flies remarkably well. I did make some modifications, like sanding the wing leading edge. If you lighten up the tail surfaces, what have you. Do look, though, I ended up with quite a bit of clay in there, because I filled that thing and then stuck a whole bunch more out on the side. So take that for what it's worth. But the airplane does fly well. I think in a standard gymnasium, you probably, with a lot of care, you might be able to get up to about 15 seconds, maybe a little more. In about a 40-foot flying site, like the Science Olympiad Nationals, I think this would actually be somewhat competitive. Definitely would do a good 30 seconds in there. And hopefully we're going to get a chance to test that out. So stay tuned later this summer. We'll see if that comes to fruition. But that being said, good little airplane. I think as a sport model, it's excellent. I do think though that with the little tail here, the trimming is very, very critical. You need to have really a little more on the instruction level as far as how to deal with that, because that does make things a little more quirky, especially if you're going to have CG marks that make the thing come out grossly tail heavy with the supplied incident settings. The supplied incident settings are basically what I ended up working back to, so you've got that. But anyway, that's my opinion on it. Fairly rugged design. The rear fuselage, I think that the fuselage quality control on wood density needs to be a little closer, a little tighter here on the rear fuselage. Remember, it builds 2 airplanes and it costs $35. That's almost as much as the Protege that builds 3 and has an unbreakable fuselage. So just going to throw that out there as far as that aspect of things. But other than that, solid design. It does fly. It flies very nicely once you give it what it wants. Sorry for Paul, he's hungry. So with that, that's the 5th and final installment on the Science Olympiad glider review. So we'll see you later. Hi, I'm Josh Finn. This is Hope. We are J&H Aerospace.
If you like this video, hit the like button.
Also, how about subscribe to our channel and check out jhaerospace.com for new free flight products and all of the tooling that you'll need to build them.
Thanks for watching.